Okay, let's talk about linked lists maybe in detail this time around. But we'll first have the basic appreciation of the whole topic. Then we'll get into the nitty gritties like the implementation of linked lists, the traversal. We'll get into the part of searching for an element, adding an element, and even deleting an element from a linked list. So I'll try to separate the videos so that in each video I'll focus on only one concept. So in this video I'll focus much on the introduction and appreciation of linked lists using a graphical interface so that it will be easy to grasp the concepts when we get into the details sections of them. So yeah, we want to talk about linked lists. So, linked list. So basically a linked list is just a list, but it contains elements that are linked together. Yeah, it's just a list, but with elements that are linked together. So you see that each and every element in a linked list is going to be containing two components, right? So that's the first point that you're going to be appreciating. Each component is going to be containing two items. So maybe before we actually get to appreciate the notes part of it, let's just take, for example, I have a table like this. Let's just say my linked list is like this. My linked list has got elements like this. Okay, let me just put them like this. So as I said already, that each element or component, that's okay. Each element or component is going to be having two items. The first item is the data part, and the other item is the pointer. So the pointer tells us the position of the next data element, right? So let's just give an instance, like we have our table like this. It is of course this is index position number 0, index position number 1, position number 2, position number 3, position number 4, and position number 5. So we have a linked list that has 6 positions like this, starting from index number 0. So let's say that the data that I have on here is A, C, B, and let's have D there. So I already have A, B, C, D, but they're not arranged in the order of their index positions. But in a linked list type of state, we're going to be having the part that if A is my first element, I need also a pointer that tells me that the linked list is starting at position number 0. So I'm going to be having to, I need to call that the start pointer. So the start pointer tells us the position where the linked list is starting at. So in this instance, our start pointer is 0. Then I'm seeing these two nodes that are free here. They are called free lists, free nodes. So I'm going to be having again a free pointer to indicate the position where we have a node, but that does not have anything. So I'm going to be starting that on position number 4. I'll explain why I did not put 5. So in this sense, if I'm starting at position number 0 and A is my first element, then B is on position number 2, so that's going to be my pointer for the first element. If from 0 I'm going to 2 because I was told that the next element is sitting on position number 2, so I get on position number 2. I get to see that there is data that is B, and next to B there is C, but C is position number 1, so I need to put in number 1 here to indicate the position of my next pointer. From there, if I get to C that is on position number 1, I need to know where the next data element is at, which is at position number 3. So I'm expecting to see a 3 there. And the next thing that I'm seeing is D now on position number 3, but D is not pointing to anything because I do not have any other data element that D is supposed to be pointing to. So we have that as -1. -1 indicates that that's a null pointer. A null pointer, it just tells me that there is nothing that is being pointed to. Yeah. So whenever I see -1, it means that that's going to be a null pointer, like that. So in 4 there is nothing, and it's supposed to be pointing to 5 in this case, so that I can link the nodes that are free. So 4 is my start position of the nodes that are free. So 4 has got nothing, but it's pointing to 5. To 5, there is nothing again because they are part of the free list. The free list contains all the nodes that are free, that are yet to be populated with something here. So in this case, 4 is my first free node, and it's pointing to 5, which is another free node again, and this is pointing to -1 because there is nothing else that it can point to because we don't have no other nodes in this. I hope that is making sense. So check this part. A free list contains two things. It contains the populated part of a free list. That's the one that is containing all the data elements. 1, 2, 3, 4. These are populated nodes of the linked list. And again, in the very same linked list, I'm expecting again to see what is called a free list, which is a set of nodes, a set of linked nodes, but that do not contain no data. So in this case, the free pointers, the free list is starting on position number 4. So position number 4 and position number 5 are components of a free list which are elements that do not have anything within them. That's basically what's happening here. So coming back here to jot down some key points, we are saying every linked list contains elements that contain each element in a linked list. So here I have 1, 2, 3, 4, 5, 6 elements in my linked list, and they each contain 2 items: 1, the data part, and 2, the pointer. And a linked list again is not enough until it gives me the pointers. Yeah, so it contains at least 2 pointers: the start pointer and the free pointer. Sometimes you're not told what the now pointer is, but it also contains pointers that are going to be my initial pointers. Yeah, initial pointers to tell me exactly what's going to be happening for me to traverse through the linked list with easy. So in this instance, if I am asked now to traverse through my linked list or to go through my linked list, I will first check on the start pointer. The start pointer tells me exactly where I'm supposed to be starting at. So start pointer is telling me that start pointer is 0. So it's telling me go on position number 0. I'm seeing that there is an A. Start pointer is telling me that go to 2 after this. So I go to 2, there is B, and B is telling me go to 1 after this. I'm seeing there is C. C is telling me go to 3 after this. And 3 there is D. D is telling me go nowhere because there's a -1, which is a now pointer. So these are the components of my free pointer, of my linked list. And that's how I navigate a linked list. I don't go in a linked list going index position by index position, one after the other. No, I have to go traversing through the pointers. The pointers tell me where I'm supposed to go next, and the start pointer tells me where I'm supposed to go first. Then the pointer of the first node tells me where to go next, and so on and so on and so on. That's basically what we have as far as linked lists are concerned. So in this case, I can actually have this as my my start pointers. Then I can even put this in a GUI state like this on index position number 1. Okay, I can have it like this. My start pointer is equal to 0, and my free pointer is equal to 4. So the 0 here, okay, I can just place the 0 inside this. Okay, pointer, I can put a 0 there. Then the free pointer, I can just put a 4 here like this. So now my linked list is going to be containing things like this, right? This is position number 0. This is index position number 0. It has an A, an A, and a 2. Then this points to the next thing that is going to be what? That is going to be now B that has pointer 1. So this means that this is index position number 2. So this, what I'm circling, are index positions. Then from B I go to 1 now, which has got the data C and a pointer 3. Then I go next now to this is of course 1, and this is now 3. On 3, I have D and -1. So I can just put phi like this to indicate that's a null pointer, yeah? Then in the linked list, in the free list now, I'm supposed to be having what? Nothing in here, but I'm supposed to be seeing a 5 there. And this points now to again position number 5, which is pointing to now. I can just put phi like this, indicating that that's empty. So this is position number 4. This is position number 5. That's basically how my linked list is going to be looking like in a GUI state. Yeah, so just know the key points are that every node has got two things: the data part and the pointer. And the pointer tells me where to go next. That's basically what you need to master. The pointer tells me where to go next, and the data element is the data part is the data element contained in that node. That's basically what we have as far as linked lists are concerned. And always know that, so this is the populated linked list, as I mentioned before. This is the populated linked list. And this part is the free list. The unpopulated linked list is called a free list. Yeah, it still need to be added some data element. So suppose that I want to add another node, which is E at the very end. E is gonna be moved. I will first check if there is something in the free pointer, if there is an empty space where I can place the E. In this case, I have an empty space, which means this node is gonna be removed from the free list and it's gonna be added now to the populated linked list, so that I can place my E here. And if my E is now here, it means that this has to change now to point to 4 instead of 1. And this is now no longer pointing to anything because that's the last element. And my free list is no longer 4 because on 4 I just placed something. It's now going to be supposed to be 5. Basically, those are the changes that I'm supposed to be making. But don't worry about the part of adding an element. We'll talk about that in its own video. So the last part that I need to mention as far as this video is concerned is how to implement a linked list. When I want to implement a linked list, I can implement a linked list using two 1D arrays. Yeah, one array of the data and the other array of the pointers. So I can just go ahead and implement and say that a linked list with the data is going to be containing things like what? I'm going to be coming through on the first one and I give it a 1, an A, which is on the first index position. Then I have a C on the second index position. On the third, I have a B. On the fourth, I have a D. And I have nothing on the fifth. So I can put that to be -1 or none. None in Python, or I can just say again here there is none, to indicate that these elements are not populated. Then I can go ahead and say now the linked list with the pointers now is going to be coming through as I have 2 on the first one, I have 3 on the second one, I have 1, I have a -1, then I have a 5, then I also have a -1. So the pointers corresponds to the data element. Yeah. So if I say data position number 1, if I say linked list data 1, it corresponds again with the linked list pointer 1. That's basically how you can implement it using 2 1D arrays. Yeah. Or you can also choose to implement this using a 2D array. But take note, 2D arrays are going to be very helpful only if the data and the pointers have the same data type. Because an array, it holds data that is of the same data type. Be it a 1D array or a 2D array, the data has to be of the same data type. So if data and pointer have the same data type, you can implement using a 2D array. Then the last way that you can actually use is implementing using classes, right? So in this case, I'm going to be implementing it in form of a record. So first of all, I will have a record that is of type node, and each node contains 2 things, the pointer and the data. So I will declare data, in this case is of type character. Then I'll also declare, I'll come on. I'll also declare a pointer that is of type what? In this case, it's of type of integer. That's basically what I have now as my then int type. Int type. That's basically what I have now as my node. So if I'm gonna be implementing this now, I would then use a 1D array, but that is of type node. You get the point? 1D array that is of type node, that is containing elements that are of type node. So I can just say linked list like this is equals to, my first element is now going to be a node with a and 2. That's going to be my first element. My second element is now going to be again a node, but with element c and 3. My third element is going to be again a node with b and 1, and so on and so on and so on. That's basically how you are going to be implementing a linked list, making use of a record. Yeah. So when you're when you're going to be implementing these, we'll use the 2D array option, the true 1D array option, and we'll use again the record type option, so as to see how we can implement a linked list in different forms. I hope you understood this, because it's going to be forming a very base of how we're going to be traversing and we're going to be working with the linked list. Okay.